All right. Hello, everybody. Welcome. Today is the 24th of October, Dallas Robotics Group. And we are going to do the usual, go around the table and talk about our robot-y things and ask questions. And so far we have a queue started of Ted, then Chris, and then the other Ted, and then open mic. So
Tom.
Tom.
I may be Tom, not Ted. I'm not sure.
So it's Ted, Chris, and then Tom. I'm sorry, Tom. I don't know what's wrong with me. Send me back to the shop.
The writing's too small.
It could be.
All right, so am I up now?
Yeah, you're up, Ted. Go for it.
Cool. All right, so first something non-robot related, but cool. The eclipse a couple weeks ago, right? Yeah, so out here in Colorado, it was like 90%, which is cool, but, you know, it's not like the total eclipse or anything. Anyway, so I got out my eclipse glasses, and I'm ready to go see it. And then I realized Saturday morning I have a couple hours to kill, so I'm messing around. And then my wife says, "It looks really funny outside." I'm like, "Oh, crap, the eclipse. I almost missed it." So I ran out there with my glasses and got the family out, and we had a good time looking at the sun. But so I've got solar panels, so I thought it was a beautiful clear day, so I thought I'd bring up on the solar panels what it looked like, and you can see right where the eclipse was. Kind of cool.
Oh, that's something.
Yeah, so that was a lot of fun, even though I almost forgot about it. But let's see. And then for robots, for the contest, I realized again I was being stupid. Oh, Ray has one. Yeah. Oh, yeah, that's nice.
Definite notch.
Yeah.
Usually it's, I call it the hump, the daily output. And that's usually like continuous there.
Yeah.
Not, it doesn't have the dip.
Yep, which is how mine is too usually. But so for the contest, I realized my son's 18th birthday is November 18th. So we were planning a party and my parents are coming in. So I'm going to have to miss it again. But next year he'll be off at college, so I should be able to make it in November.
Ted, you don't look old enough to have an 18-year-old.
I am.
You are.
Yep. It's trying to keep up with the 18-year-old that's keeping me young. Lost some hair over it, but and then I have a robot question. So, and I probably know the answer, but I keep trying to figure out how to include the magnetometer in it with the gyro, except the gyros are just so much more precise than the magnetometer and accurate that the magnetometer drifts 10 degrees plus or minus, and especially if you move, and I don't know, I know the answer is probably to use what do you call it, a filter, but yeah, I just haven't had any luck in it. The math on what's the filter called?
The Kalman or
Kalman? Yeah, the Kalman filter math is. I've tried it a couple times and it just kills me every time. I just can't get it to work. So I was just wondering if anyone else had any success with using magnetometers in their robots.
I don't know. I've had pretty good luck outdoors with the B&O 055. It seems to work pretty good. I have to do the weird, figure 8 calibration in 3 planes, but and on a little display it shows me, like the system, the gyro, the accelerometer, and the magnetometer. Mm-hmm. It just has a number after it, 0 through 3.
Oh, and, the calibration or whatever they call it, the confidence.
Yeah.
Yeah, and so I'm using a B&O 055. So but I do my testing indoors usually, and then eventually take it out. And so maybe I just need to take it outside and test the magnetometer outside more instead of mostly testing it indoors.
Yeah, there may be. I don't know. Do you testing it over a concrete floor or something?
Just a wooden floor, so
Wooden floor.
it just could be the nails or screws or whatever. I don't know.
Yeah.
Ted, have you moved the magnetometer away from the motors in your robot?
No, there's not a lot of space in the robot. Maybe I should build a mast or something. I've seen other people do that. So
That's the reason why they do it. Yeah.
yeah.
Couple of feet high, apparently.
Yeah. Okay. That's a good
Size.
suggestion.
No, mine's like 1.5 feet away from my motors.
Okay.
I had good experience with the one magnetometer project that I did. I talked about it here a couple of weeks ago. I forget the model number I was using. It was strictly an indoor application, but it worked out quite well. It's not trivial, but it worked.
Yeah. All right. That's all I had.
All right, cool.
Hey, Ray, the question I had before you leave this topic, when you're using do you do the figure eight stuff every time you run your robot, or do you capture the limits and just use them if between runs?
Pretty much if I leave it on, I only have to do it once. But if I turn it off, I've got to redo it because it doesn't keep any of that.
In the application I built, the calibration constants are stored in the double EEPROM of the Arduino. And then if you don't do a calibration within a certain timeout period, then it just uses what's stored.
Yeah, well...
does the B&O have a way to capture those values?
I
think it does. I don't think I'm doing it at this point.
Right. I want to say the registers exist, Ted, but I haven't really dug into the pretty massive data sheet to figure out how to do it.
Well, I think Adafruit has libraries for that.
So they have a pretty good library.
Yeah,
and they have a library that lets you. So, like on the hover sim, I have have one firmware that when you run it, it just captures that and writes it to double EEPROM.
Okay.
And then the other firmware, it just always reads it from double EEPROM.
Yeah. So that sounds good. I knew there was a way. Just simple magnetometers. Unless you change the environment greatly, you can just calibrate them once, and they're pretty good. That's the reason. That's why it works in your car. Yeah. But let's see what else is. So anyway, I would be interested in exploring alternative ways, because you're right, the Kalman filter is a real troublesome learning thing. And like I say, it really upsets me because if so many people have obviously solved it, you would have thought that somewhere there's just a real straightforward plug this number in, plug that number in.
Yeah.
Now there is a video in the DPRG library, DPR clips, by Francis Grover. I think it's Francis Grove. And he's the one who developed the system that goes in the NASCARs. They show a screen where it shows all the cars going around. They're tracking them, and that uses pretty much a GPS and odometry. Okay, and I don't know if he uses a compass in that or not, but one of the things I remember him doing, she said made it simpler, is don't try, when you look up most academic papers, it's all matrix calculations. All right. And what they're doing is, he said what he prefers to do is like solve the problem for X, the X direction, and solve the problem for Y direction. And then I don't know, there might be another thing that he does, but instead of trying to do it all as one big calculation, he actually separated it into directions. Okay, so
Yeah, vectors.
vectors, yeah. Okay, so like if you have X, Y, you're going to at least at the minimum, I think, have a 2x2. Okay.
Okay.
You know, he wants to get it down to just a 1 or a 1x2, and so he just said that was easier to do. But that his talk, and I got to, is would be well worth looking at. It's on DPRG clips somewhere, and so like I say, that might give you some ideas. Okay, now a while back we were talking about autopilot, yeah. Well, it's now done on ARM chips, and they do use a Kalman filter on those. But if you go back in time to when it was done on a Mega, okay, which is any version before, I think 2.6 or something like that, they used what they call a complementary filter, okay, which is a simpler calculation. And I did actually, when I got my highest score on RoboColumbus using an autopilot, which was based on a Mega. So it's good enough to get you down to the cone. Okay. And so that's another, and that code is available. I don't know if I'd want to sludge through it, but it is available in their archives. Okay. So just let's see, what's it? Just a few points that might be useful, and also that course that I talked to you about by Clyde Brimmer, I believe it was last week. He goes through it, and before he gets to Kalman filters, he uses what is it? Bayes theorem. I probably have it wrong. It's where you have it's the foundation. It's a little simpler approximation, and that also is very good. It's just a little more computationally intense, but if you're using a Raspberry Pi or something like that, it's not a big deal.
Yeah.
And it's exercise in one of their homework problems of their exercise is to develop a Python script to do that. And it wasn't really, by the time you get to that point in the course, it's really not too big a leap. But from there, they go to Kalman filters, and that is a big leap. So anyway.
Yeah, well, so Doug, I've been working with I just got Teensy 4.1, and that thing is a beast.
Yes, it is.
600 megahertz, and it does really fast floating point. So yeah, I would have no trouble doing it.
Yeah. No. So the main thing you got to be really careful. They are not 5.5 volt tolerant on any pins. I.e., you put 5 volts on a pin, that pin's dead.
Yeah, and I've been using the 3.5s, but you can't get those anymore.
Mm-hmm.
The 3.5s you can't get anymore.
Oh yeah, I my favorite was I didn't get it. I got a 3.2, I think it is.
Yeah, 3.2 and 3.5 are both 5 volts.
Yeah, there's some pins that you can't, but there are a lot of pins that are. Yeah, I love that. He stopped making them, I guess, because of COVID. He couldn't get the parts.
Yeah, you couldn't get the chips for some reason.
Yeah, so he only makes the 4 and the 4.1, which are essentially the same board.
Yeah.
Yeah. Just,
So is Teensy C++ or is it a Python?
C++.
it's C++. Yeah.
I wouldn't be surprised if someone made like a Python.
Yeah, I wouldn't be surprised if there wasn't a port, but I mean, yeah, I wouldn't be surprised at all.
Yeah.
Yeah.
Speaking of magnetic declination, last week I was surprised. Doug, you said it was like 12 degrees in our area.
I can't remember. I don't know. Somebody said it was. Somebody gave a number, and I said it was. No, I thought it was at least twice that. If I remember.
Yeah.
Right. Yeah.
I was looking it up in my area. It's minus 6.76 degrees.
Yeah. Yeah. Now you have to. Yeah. I was going to say it was about 8, but you're saying it's 6. Yeah. But
Yeah.
that's
6.76.
yeah.
So I would think Pat may have 12 degrees or something.
Yeah. So
Oh yeah, probably.
Yeah. Yeah. His is probably, like, instead of pointing up to north, it's like
due west, huh? No. Could be.
I'm 9.12 degrees.
9.12. Okay.
Really?
That's not that bad.
That doesn't seem like much.
The other way up from you guys.
Yeah. Oh, okay. Okay. So.
Anyway.
Yeah.
Sorry to interrupt.
Yeah. There's a website that you just tell them I want to see it's like on Google Map almost. You tell them where you are and it tells you the exact value.
Mm.
So, yeah.
I just looked it up on Google and I find it right away.
Yeah.
Yeah.
I don't have to worry about it here. I could see the North Pole from here.
It's that big flag flapping in the.
Compass point down.
Yeah. Yeah. Yeah, that's the other thing is inclination. I'd be, this part where,
Mhm.
I would imagine up there it's really pointing down into the ground almost. It'd be interesting to know if you took a normal compass and you just put it on your hand, how is the needle tilted? Is it tilted downwards when it's pointing north, or magnetic north, or that'd be cool.
No, all I know is that the sun in the summer is about 46 degrees in the sky, and then in the winter it's 20-some degrees.
Yeah.
So Doug, I've heard they weight the compass so the needle stays level. And compass for the southern hemisphere is different because the other side's weighted.
I don't know. I do know if you get, one of the little cheap compasses from, like a dime store or something, well, the $2 store, those that are just kind of like floating on a pinhead, they will tilt.
Yeah, I'm talking about the expensive ones.
Yeah, yeah.
Yeah, no one ever made a sun compass. I'm surprised.
All right, that's all I had. So,
That's cool.
Chris, you're next, I think, maybe?
I think, Chris and then Tom.
All right. Well, good to see you, Carl. You weren't in the last 2 meetings, I think, right?
No, I've been out, unfortunately.
Yeah, so I'm trying to find some time again here and there to do a few robot things on my Romy platform. It's, you remember this, but just to refresh your memory, right? So this is my Romy platform.
Oh, is that interfering with your microphone?
That's the ultrasonics.
Ultrasonics
is that thing happening again? Yeah.
Yeah, it's buzzing.
Yeah.
Countermeasures, Chris. You brought your own countermeasures tonight.
Now, so I'm trying to get back into it, but I realize I barely remember sort of, because where I left it off was, in the middle of working on some occupancy grid logic, and I realized I didn't have enough documentation. I could barely figure out even how to start everything up, right? Because I got this hodgepodge of, Python scripts that all work together one way or the other, and it's like, which one do I have to even run? And so I started doing a bit of documentation. I'm quite proud of it, actually, because, well, it's necessary. I did a couple diagrams, but I'm also, writing down sort of what everything does. But this is sort of where I left it with respect to the waypoint navigation logic, and it's this diagram leaves out some details, but I think I'm gonna find this useful to refresh my memory. Behind the next level of detail, there's, for every one of these boxes, or for some of these boxes, it's actually more than one Python script that's in charge of doing that. In some cases, it's one Python script that has nothing to do with RAWs and just knows how to talk to the hardware, and then the other half of it, is the half that knows, how to publish the information on the RAW. So that's like that with some of these Python scripts. I've split them in half that way, so I can use it in RAWs or without the RAWs if I wanted to. So that's the waypoint navigation, and you can see here. I don't want to call this subsumption sort of architecture here, but there's an arbitration piece to it that takes in the different, speed commands or motor commands that are coming from both from navigation, from obstacle avoidance, and ultimately from the human if he wants to step in, right? So my arbitrator is basically deciding who gets to actually control the motors, and right now priority 1 has the human who can step in and avoid a crash. Priority 2 is the obstacle avoidance logic, and priority 3 is the waypoint navigation. Right. So that's that. So again, this is more in part for my benefit, but also if I need to explain it to someone else. Where that was all working, and then I started working on occupancy grid, and we talked about it last week a little bit, and that's where I was totally missing some pieces, and just recently found a missing piece. It was some utility that I had stuck in another folder, and I knew I was missing something. I was missing this piece here, this box here. I don't know how I had done it. I knew I had done it. So anyway, like I said, I didn't write enough down to remember how to even fire all these pieces up. So, but my occupancy grid logic, there's really just 2 pieces to it. And I just wanted to illustrate that because Tom had expressed some interest in that the other day. And it's, in the end, relatively straightforward. All I'm doing really is I'm taking in my LiDAR scans. Right? They're coming in here, let's just say 10 hertz for the sake of discussion. And think of the LiDAR scan as, in polar coordinates almost, right? Because you get pairs of an angle and a range. For every angle, you get a range. So let's just say 360 angles with the corresponding, range readings, right? So you get that. The other thing I need to know on my occupancy grid is where am I currently and which direction am I facing, right? Because what I need to do with these 2 pieces of information, I need to now take the LiDAR scan and convert it into something that's represented in world coordinates, right? Because the LiDAR scan, the LiDAR is at the center, it's 0, 0, and then I get 360 range readings. But I need to know what pixel to flip inside my occupancy grid, right? So I need to convert this LiDAR scan into something that has actual XY coordinates to it, and that's what what this box is doing here, where it says project the laser scan into world coordinates. And what comes out is a point cloud, which visually looks the same as a LiDAR scan. In fact, if you use the RAWS feature that displays all this, and if you ask RAWS to display a LiDAR scan in a point cloud, I mean, they all look the same, right? Because it's all just, pixels.
It's only two-dimensional.
Yeah, it's all two-dimensional. But behind the scenes, it's very different, right? The point cloud, again, has actually X, Y, and Z coordinates, which I don't care about. I consider everything to be,
That's what I'm saying. Yeah, that simplifies it a lot.
But still, you have X and Y. In the point cloud, you have X and Y. In the LiDAR scan, you have vectors. You have an angle and a distance, an angle and a distance. Right now, here I have X and Y, and it's not just any X and Y. It's in world coordinates, right? Because as the robot moves, where the obstacle is now somewhere else in XY space.
Yeah, right. So let me ask you this, Chris. I think this is what I see you doing, and you tell me if I'm wrong. You're taking your polar coordinates, converting them to rectangular coordinates, which...
Or X and Y components.
Yeah, X and Y components, that's fairly easy to do. I just sine and cosine. And then you're offsetting them by your understanding of where your robot is, the XY of your head, and then the headings, your direction that you're facing. But so you take your XY components of your LiDAR, and then offset them by the XY of the robot.
Not just offset, but you also gotta rotate. Right, because the robot can turn too. It's not just an XY shift of what I'm seeing with the LiDAR. I also gotta rotate it. So you gotta fully sort of transpose all these coordinates. Now, in this case, I didn't have to do the math. There's another thing where I did the math myself, where I'm trying to de-warp the LiDAR scan. But here, I didn't have to do the math from scratch. There happens to be a RAWS function I can just use that does this box here. So
cool.
But the math is straightforward. But you got to remember to rotate as well. Yeah, it's a lot of sine, cosine, and you got to shift the X and the Y. But you also got to do a rotation, right? Because the robot's orientation changes. It's still relatively straightforward math, so it can be done from scratch. I have done it from scratch.
So let me ask you this. So the front of the let's just assuming you were able to control everything, and you say on my LiDAR straight front in front of me, so my robot's front is 0 degrees, but my heading says I'm 90 degrees. So you're saying I now have to just shift that LiDAR map by 90 degrees. Is that, or rotate it?
Exactly. You have to
all right. Thank you.
Rotate everything. Yep.
Thank you. Okay.
Yep.
When I was working at programming my tri-wheeled robot, my omni-wheeled robot, I actually had to go through 3 of those transformations. One from the wheel axis, one to the robot local coordinates, and then a third one to the world coordinates. Yeah. And I did the math the hard way because I hadn't done math in a long time.
And that's one of these examples where RAWS helps, because again, there's just certain features in there that are not complicated, but they're very useful. It does exactly this math here. It takes this as input, puts out a point cloud, and all the points are in absolute XY coordinate, right? World coordinates.
Chris, I'm curious, at some point you need to decide which direction your world coordinates point in. Is that arbitrary, or is there some other?
Well, yeah, I mean, the robot starts out at XY 0, 0, and my heading is 0, which I'm trying to remember again because I haven't written this down. If this is facing this way or that way, if I drew it on the map, I think if my theta is 0, and if I draw a regular XY kind of coordinate, I think my robot would be facing left. Again, that's one of these things I don't remember. Got to write this down. But it's arbitrary in the sense that I always start out at 0, 0.
All right. So basically, whatever direction your robot is looking in when you put it down on the ground
Exactly.
becomes
I do not have a
north, for
compass.
example.
Everybody's complaining about the compass. I don't have a compass. I don't exactly. I make it arbitrary. I do have sometimes for some tests and for repeatability's sake, I have some markers on the floor that I put my robot down, and I put it always in this, or put it in the same place, more or less same orientation.
Got it. Thank you.
Yeah, but it's arbitrary at the end of the day. But the thing is, once you have this sort of XY coordinate space point cloud, then it's relatively straightforward to sort of then turn that into an occupancy grid map, because all you got to do is you just kind of continuously update an image, if you may, right? Every pixel in there represents a certain amount of space. I've played around with every pixel representing a square inch of space up to 10 centimeter square space. And that's one of these things I need to experiment with, right? For this occupancy grid map to be useful, it doesn't need to be super high resolution. It's just going to take actually a lot more processing. But the updating of this occupancy grid map is where I'm at now. Some very basic algorithm. It's not very smart, but the concept is straightforward. You start out with every pixel at a value that you just consider to be representing unknown, right? I don't know what's there.
Yes.
Yeah, and then what you do is you draw a line basically from your from the center of your robot to the first sort of pixel in your point cloud. Right? You literally draw a line as if you were trying to draw in an image with a regular line drawing algorithm, if you may. And every pixel along this line, there's nothing there, because otherwise you couldn't have reached that, the target on the other end. So you clear those pixels, you mark the pixel on the other end, and so on. I'm playing around with this. Do I make it Boolean? Do I make it more probabilistic? I mean, those are the kinds of things. I want to keep it simple, but still sort of useful enough. So I'm playing around with a sort of a range of values here. So it's not just Boolean on and off. And so I got a lot more. It's not working right now. It's not working well at all, but that's where I'm at right now, and that's what I want to sort of improve next.
Chris, with some of the papers I've been reading, one suggestion was that if you have reasonably precise sensing, and LiDARs, I presume, would be reasonably precise with respect to the grid size you choose, that knowing whether a grid cell is occupied or unoccupied or unknown is enough information? Thoughts?
Yes. Now, the LiDAR is accurate to a point. Sometimes you don't get a reading for a certain sort of
really shallow angles.
You get noise sometimes. So I think it's helpful to have more than just a Boolean, right? And then you got to decide if right now, this moment, I saw something there out in the distance, and now if a split second later that thing is not there, what do I do? Do I consider it there or not there? Yeah. Well, that's why you usually want to keep track of a range, right? I mean, it was there. So right now, if I see something, okay, I'm going to consider it to be there with high degree of confidence. If in the subsequent sort of updates of my LiDAR scan, I don't see something there, I reduce the value, right? And at some point, well, I haven't seen it now for like a second, right? There's nothing there, right?
So that's sort of probability along the time domain.
Yeah.
It's fairly common from my readings to use probability when you're using things like ultrasonic sensors because of the difficulties of pinpointing exactly what you're looking at. I hadn't thought about it with a LiDAR. That's a good point.
Yeah, and again, I mean, I'm mainly experimenting, and I'm somewhat reinventing the wheel, but that's just because I want to in this case. And I want some balance between a simple algorithm that I can understand, but I want it still to be useful.
I'll throw out one more question from one paper I was reading that was addressing the issue of simplified grid occupancy. That particular researcher suggested that a grid size just big enough to hold the entire robot was adequate for basic navigation.
Yeah.
That struck me as a little strange because I'm thinking, people are more likely to say it's a 1-inch grid, it's a 5-centimeter grid or what have you. But one cell per size of the robot seemed a little coarse. What's your thought on
That does seem a little coarse. I mean, one of the things I do want to be able to do, I haven't found a way to do it with just the ROS stuff, the ROS navigation stack, right? I do want the robot to be able to squeeze through a narrow opening where it's just sort of barely able to squeeze through. I mean, just as a challenge to myself, right? Why should the robot not be able to go through this passage? It's wide enough so if you make it too coarse, right? If your resolution
You'll
of
never
everything
know.
is too low,
Yeah,
it's just not going to want to go through.
I would agree with you.
So, but 1 inch, I'm thinking a 1-inch square grid is probably overkill. Maybe 2-inch or 4-inch square will do it.
Well, yeah, if you're thinking about, getting your robot to move into spaces that it can actually move in, you're more or less concerned with, okay, how wide is your robot? And is that space just a little
Yeah, I mean, my
wide?
robot is small, right? It's a what is it? An 8-inch diameter platform, right? So it's not a big
Right.
robot. So.
Yeah. So this is updated, I guess, at 1 hertz rate then?
Yeah, so the map, and that's somewhat arbitrary. It's typically done at a relatively low rate, more because it's expensive, right? So publishing this picture, which when I started out, I had a grid of 400 by 400. And every pixel represented a square inch. So 400 by 400 is what? 160,000 or 16,000? Help me out. Anyway, it doesn't seem like much. It seems like a small image, but nonetheless, I mean, with the overheads involved, doing sort of a lot of things in Python, it does suck up a lot of resources. It does suck up a lot of bandwidth on the Wi-Fi network too. I mean, some of the things I have to be mindful of sometimes is, it's maybe not very expensive for some big chunk of data to go from point A to point B on the robot, right? If you look at this diagram, this is all on the robot, right? So however big a given laser scan is, it's not that important. Right? It's all data moving around in memory on the robot. On a Raspberry Pi 4, it's not a big deal. Now, when you then throw in the PC on the other end of the Wi-Fi network, that's the ROS sort of running my ROS user interface. Well, now all of this data that I want to display, which for sure is going to include the LiDAR scan and so on, and some of these other things that are updated very frequently, now you're putting a lot of data on the Wi-Fi network, right? And sometimes because of the variable latency on the Wi-Fi, the receiving end can get a little confused. The more you try to publish there and send over Wi-Fi, that RViz utility that's going to display all that for you can occasionally sort of fall behind and get confused and doesn't know anymore what to do. I have to restart it so it gets unconfused. And, so again, I have to be mindful of how much data I put there on Wi-Fi, and that's why, that's why I don't want to make this too big.
It would be really nice. I mean, I know it would be really nice if somehow these spinning LiDARs would allow you to select the points that they send over. I know you're grouping into, I think, groups of 10 or something. You said, I think you had like 12 virtuals, you said earlier.
Yeah, I'm putting it in this case for some of the navigation obstacle avoidance. I'm converting the LiDAR scan into 12 virtual distance sensors. Now for the occupancy grid, I'm not doing that, right? I'm taking the full LiDAR scan.
Okay.
So the 12 visual sensors are more for simple algorithm that just want more than three distance sensors. So yeah.
On that RP LiDAR that you have, can you? I mean, how fast can you capture the data over the
10 hertz?
No, I know it'll spit out that much. I'm just curious. Can you speed up the? What am I trying to say here? Can you speed up the serial port or anything?
That's not the bottleneck. The bottleneck is the rotation speed of the LiDAR. It's designed for 15 hertz, which is about twice of the A1. This is the A2. You can crank it up to 20. Things are starting to shake at that point. So it's really the mechanics of that LiDAR that limit what you can do. The serial port, is not so much the limiting factor, although I don't remember if you end up getting a loss in angular resolution when you crank up the speed. I honestly don't remember. But even if that's the case, that would be fine. It's really the mechanics that don't let you really go higher than 15, 16 hertz. Yeah, so I'm gonna experiment with this logic here a bit more, see where that takes me, and at some point I wanted to do sort of just for sake of one application where this could be useful for people. Not everybody has a LiDAR. Some people have just a single TOF, distance sensor of some sort, right? Or some other sharp IR, which I also have. But there are some very good and precise, just one-dimensional TOF LiDARs, right? So if you just have one of those, a single one, if you think about now you're moving your robot around, right, and you're turning, you can populate an occupancy grid with that information, right? That's where the occupancy grid then suddenly becomes a lot more powerful, right? I mean, with a LiDAR scan, frankly, you could just look at the instantaneous data and make decisions based on that, right? And you'll do pretty well. But as I mentioned before, you can now feed all the data into this occupancy grid too, and even if you don't have a LiDAR, you can populate the grid with information you do have. And now it's almost like you have 360 degrees vision, right? Just because a moment ago you were facing this direction, you turned, and voila, you've populated the occupancy grid.
Yeah. I put a link in the chat of an Instructable that has a real simple example of that. And so he's using a grid size of one robot size, okay? And he's just demonstrating the principle. And so he has an ultrasonic, and he moves one square, and I believe he looks forward, left, and right. So he has he might look 45, but I don't even think he does. I just think he goes forward, left, and right. And then based on that, he runs, a mapping routine to get to a square, and then makes a decision. And then he goes one more square and does it. There's a lot of stuff in that little simple Instructable that can really be useful if you're new to the subject. And it's not as sophisticated what you're doing, Chris, but there's some good stuff there. And you have to look at his videos to see how it works. But there's also down at the bottom or the very end of it, talks about how he chooses the algorithm he's using to choose his path. So anyway, I just throw that out. But so you're like you were saying, you don't need a LiDAR. You can literally do it with a single ultrasonic.
Yeah. What you do need is you do need to know where you are, right? I mean, that's
Yeah.
Your current X, Y, and heading, you do need to know that. Otherwise, you don't know where in your occupancy grid you're supposed to make a marker or clear something off. So it is important to have accurate sort of pose information.
Yeah. In his case, he's using the same thing you do. When he turns on, forward he's at 0, 0, and his forward direction is forward, and he knows where he wants to go. So he picks I want to go to square 2710 or something. And then based on that, he tries to drive to 2710. Like I say, if you've seen it, but it's a good, just to show how simple you can be if you want to do it.
Yeah.
Yeah.
Doug, that's nice confirmation. I was looking at that Instructable earlier today. Thank you.
Yeah. Yeah.
And so the other thing I started doing is I started looking a little bit at ROS 2, since ROS 1 hasn't been updated in many years now.
Mm-hmm.
I think ROS 2 is, ready for regular use now, but I got to see what I actually have to change. If it's going to involve a lot of changes I have to make, then I may not bother, but I don't think it's going to be too bad. So I'll probably do that at some point, switch over.
Chris, thank you for putting together and sharing your software architecture. And I find those very useful.
If somebody wants to look at RAWs, I'm just going to say that if you go back in the DPRG clips and look at some of the things that Paul and another gentleman, Jason, have put in 2 or 3 tutorials over time. So you can do DPRG clips, ROS, I think, and it will do. And if you were in ROS 1, they recommended this book right here, which is A Gentle Introduction to ROS, which is fairly easy to understand. But I don't know, Chris, does a similar book exist for ROS 2? Do you know?
I don't know, and honestly, I haven't looked. I do have a good ROS 1 book. It's called Programming Robots with ROS. I found that also be very good. I don't know what's out there for ROS 2. I haven't looked.
Okay.
Doug, that book you just showed me is available as a free PDF download as well on the internet.
Yeah, I believe it is, but it's one of those things that it wasn't I don't think it was very expensive either. I can't remember. But I bought the book, and it's so. What was the name of that, Chris? Do you have a title?
The one I've used before is called Programming Robots with ROS.
Robots.
That's opposed to the harsh introduction of being pushed in the ROS swimming pool of very cold water.
Yeah.
Less of a shock to the body, I guess.
To ROS.
Yeah, it looks like it's an O'Reilly book.
Okay, I'll put them in.
I was just Googling that, and it has both ROS blank and ROS 2.
Which one? Which one, Dave?
What I'm saying is Programming Robots with ROS brought up ROS and ROS 2.
Oh, okay.
PDF versions.
Oh, okay, cool. That's good to know. So, Chris, was that one that you had? Was that ROS 1 and ROS 2?
I think it was just ROS 1. I mean, that one was published in 2015.
Maybe there's a later edition.
Hey, Dave, can you go ahead and put in the link?
Well, okay. What I'm saying is that if you type in robot programming with ROS 2.
Yeah.
and it's got a PDF.
Okay, cool. A PDF.
Yeah.
Quick, download it.
Yeah.
A concise introduction to ROS 2.
Yeah, I found that on Amazon just now. Right? A concise introduction to robot programming with ROS 2. Yeah.
Is this a legitimate download, or is this where they've kind of like stolen it? Anybody know?
Well, when I brought it up, it says a book, and it says one of the options is to print it. I don't know.
Probably stolen then.
Okay.
No, it just apparently does the introduction. Doesn't look like it does it all.
No respect for copyright laws at all.
Well, it would be interesting to know if it's on Amazon. It should be. How can I not do that? Okay.
It's available from Amazon. Oops, where is it? Kindle is $28 to $44. Paperback is about the same.
Oh, so that PDF link, that seems to be legit. I mean, that company that construct them, they sell learning material, they sell courses and so on for us.
Yes, I agree. And what I'm saying is that if I went on to the one that says Amazon, they have both a Kindle and a paperback version. The ranges from, the paperback is from $40 to $46.
Yeah.
Is the PDF just the lost leader then, or?
No, it's like Chris says, it's a school thing where you can, become a member and all that sort of stuff.
So,
Yeah.
I don't know what it gets you. The thing is, if you try to take the PDF, it's just the cover sheet essentially.
oh,
Yeah, I mean, the concepts are the same, but what I'm finding in ROS 1 and ROS 2, I mean, there's some of the plumbing works a little differently, and, so it's, for what I'm doing, from what I've seen so far, yes, I have to change my Python scripts. There's certain things are just done differently. But again, the fundamental concepts are the same.
Yeah. I would guess if you're starting now, wouldn't it be more appropriate to start with ROS 2?
Yeah, if someone were to start out now, I would agree. You probably want to start with ROS 2. You're going to get better support.
But, Chris, how hard is it to go into, like you said, you were able to go into their library and essentially steal a function. Is that pretty easy to do? And are they well documented functions and useful, or?
I would say yes, because there are all these pieces, right, that are in some sense meant to just be used as a building block. And I'm trying to find it. In fact, where is that thing so I can show you, in fact, what that looks like. And the most of them are fairly well documented. I think it can vary a bit in terms of how good the documentation is. But for the piece, for example, that let's see if that comes through. For the piece that I mentioned where I said, I didn't have to do the math from scratch. I just used sort of a ROS function that does that. So I had to obviously find it as part of this laser geometry package and whatnot. And then if I'm just looking at this, okay, here's one piece of C++ code I had to write, probably largely based on an example that actually was part of the web page that documents this. It's 75 lines of code, and it basically does the thing I needed it to do. It waits for a laser scan. It waits for sort of all the information it needs to do the coordinate transformation, and then you publish a point cloud. Now, it does get a little bit into the nuances of how certain things work in ROS, but to be honest, I can't claim to fully understand everything that's in this file here. I've put this together based on the examples I saw, right? And modified it accordingly. That you don't have to be an expert in all the sort of ROS lingo that's in here. I don't know the ins and outs of every line of code here, but I knew enough to take an example and turn it into something that does exactly what I needed it to do. Take in a laser scan, put out a point cloud that's referenced in world coordinates. So you didn't have. So I didn't have to. I guess to answer your question, I didn't have to pull something out of somewhere where it's not meant to be pulled out of. This is meant to be a library of sorts that's a building block for you to use.
Sounds like it'd be pulled from a nasty place. I don't know.
Yeah. I think there's one thing, I tried to do this once before, and one thing that I ran into that I know you have to be cautious about is you have to use the coordinate systems that ROS uses. Otherwise, I want to say, like, if you use Dave Anderson's, your robot's going forward in the Y direction. But in ROS, you're going in the X direction, and Y is 90 degrees like this.
Correct.
Where if you're in David's thing, this is Y direction, and X is like this. So it's a little different.
Yeah, that's true. When it comes to coordinates, it's probably the one thing that takes a little while to get your arms around with all the coordinate transforms and so on. And
I always think, X should be to the left and right, and Y should be up and down, and anything contrary to that is, my mind wants to force it back into the other direction.
Yeah, but so like what I was trying to say was like, so this in David's system, north is 0. Okay, if you want to think of it, and east is your x-axis. But you notice that I moved clockwise to get there. Okay, so if I move this way to west, it would be 270 degrees. But in ROS, this is 0, and this is 90 degrees.
Yeah.
And this is 90. This is minus 90.
Yeah, X and Y have the same meaning, right? It's just a question of what direction are you facing when your heading is 0 degrees? What do you consider 0 degrees to be?
And the rotation. So like I say, in David, you go counterclockwise to get to east, and clockwise. To go clockwise to go east,
Right.
And
Well, it's like compass points.
yeah, and
zero is north.
In this, you're going counterclockwise to get to 90. So it's, I mean, when you look at it, you just got to make sure you understand it.
Use a mirror. Hold it up.
Yeah, I've played with it with David's stuff for so long that now it really gets frustrating when I try to do it the way that the rest of the robotic world does it. So, just kind of weird.
It's all for me.
Very cool. Thanks. Yeah.
Yep.
All right. So I think next in queue we had Tom with a question about the Roomba, and then way back I think Mickey had a question back on IMUs and Raspberry Pis, and then as far as I know after that it was open mic night. So Tom.
Okay. As I mentioned, in years gone by, I've collected about 7 Roombas. One of them is a clone called a Coolvac, very old clone. The other 6 are actual iRobot Roombas, and it looks like 4 of them at least have sufficiently up-to-date firmware to support serial interface control. The 5th one might have, but it looks like the firmware date is too old. I haven't attempted to confirm it yet. My most urgent issue right now is testing the 7 battery packs I have to see if any of them are any good. Some of them seem to hold charge for at least a while, so we'll see. I've built an RS-232 interface, which I admit I have to show you. Salvaged parts off of some old piece of junk out of my junk box, and the hardest part. This may look good. It's gold-plated now. This is the doggone 6-pin mini DIN connector that's required to plug in. I have nothing that was actually going to fit in my junk box. So this is a completely rebuilt mouse PS2 connector. Those are really hard to take apart because they're packed with plastic. But it's now made up and works very, very well, and has all the right wires in all the right places. So I can at least see things coming from the one Roomba that I'm currently playing with on my desk here. First question of a practical note, and that would be the suggestions for a Windows app that makes it easy to interactively talk with and look at what's inside an iRobot in terms of using that serial interface. I can talk to it with real-term, but that's pretty awkward. I saw something called RoombaCom, which I believe a past member of this group has been heavily involved in. Paul Bouchier, if I got that right?
Yeah. Paul, he was online a couple of weeks ago.
Yeah, there may be some others I don't know.
Yeah, Jason is probably in that too. I can't remember.
RoombaCom, of course, is written in Java, and implementing Java stuff on a Windows app, when I haven't done Java in probably 20 years, is a real pain. There may be a shortcut or there may be another application. So that's sort of my first question. An easy, quick way to get some form of interactive control tool running in Windows, just to play with what's going on inside these things. And if anybody has advice on batteries, especially if I have to replace the cells in them, they're all nickel metal hydride. So my default plan is to go to IKEA and get a bunch of AA nickel metal hydrides if I have to.
Yeah.
Thoughts?
I got one thing. I'm not saying it's cheap, but one of the things you can do is you goes to Battery Plus, and they'll rebuild one of those things for you. They'll take it apart and rebuild it.
Sure.
The iCreate robots actually came with a battery module that fit, I want to say AA batteries or something. It might have been C-cell. I can't remember. So I'm not recommending that either. That's kind of expensive. But they did do that. And there is also
the batteries on like Banggood and stuff, the old ones.
Yeah,
might
and
even-
I want to say you're right. I think you're right, Ray. But I think there's also, which if you're really serious about keeping one of them suckers running, I believe there is a lipo battery, a new lipo battery. The problem you have with the lipo batteries is you can't charge it up with the metal nickel hydride charger.
Exactly. Yes.
So you have to figure out. I'm not sure exactly. I know they have it solved. I think they put the charger inside the battery pack.
Yeah.
But they're not as cheap as the other ones because,
Yeah, I have a tendency to build my own battery packs, anyways, and I've built 2S and 3S LiPo packs with built-in battery management system chips inside them. So I'm pretty comfortable with that. But I'll probably take the easy way out if I have to, and build a pack out of nickel metal hydride cells.
Yeah, and there's a book that's kind of like the Bible of that. I'm trying to think of what it is. It's something about like building. Oh, here it is. Extreme Tech Hacking Roombas, and it kind of goes. I think it goes through all of the parts all the things you need to do.
Show me the title again, Doug, please.
It's called
Hacking Roomba.
Hacking
Extreme Tech Hacking Roombas.
Yep, I've seen the references to it. What year would that be? Or a revision number?
It's old.
It's probably 20 years old now, right?
Well, probably more than that. Where is it?
You think you can still get that somewhere?
I want to say it looks like 2007.
Yeah, okay. I know the book. I know what you're referring to. That's for the website, and the website's still up as well.
Yeah, 2007.
That's where he talks about the RoombaCom application.
Yeah, and that's published by Wiley. Yeah, Wiley.com.
And the author?
Todd E. Kirk?
Yeah, that sounds.
Yeah, Todd E. Kirk, yeah.
Okay, I know of it, thanks.
And it's supposed to be...
It's James T. Kirk's brother, maybe?
Yeah. I will say, if you get Paul on, there was a DPRG-owned robot, which was a turtle robot, which used ROS 1, and Paul and like I say, and I can't think of Jason's last name. I know his email, but I don't know his last name.
Hendricks.
Yes, James Hendricks. Yeah, I think you're right. Right. And he, both of them are, very smart, and they spent a lot of time on Roomba.
Okay, good.
So are these for some of the oldest models of the Roomba, though? The
particular ones I have, my newest one's a Model 530, and I have a 4225, a couple of 4100s, and a 4000. I have a Roomba Pro, which is the oldest one I've got, which has no serial interface.
Yeah,
and I've got something called a Coolvac, which has no serial interface.
Essentially,
Coolvac apart, so it's not good now.
Yeah, if you get one with the serial, I think the very first serial port one may not be as compatible as the later ones. But after that first model with the serial port, I think they're all pretty much the same.
Yeah, it's going to have firmware after October 2005.
Yeah.
So I've been confirming that with mine because there's ways to ask it what the firmware is.
If anybody wants one of those things, I've been cleaning out my garage, and I think I've got one to give away. So, I've got two things that I thought people might be interested in. One was, I think, an old Roomba, and the other one was I might have given that to Mike. I don't know. I may have already given that one away. The other one was an old HP XY plotter. Okay, and the problem that most people have with those is they can't hook up to it. But there's a hack on the web, which I got hold of one of these guys, and I did the hack on the web, which is what you do is you actually go into the old UART chip, and you solder wires to certain pins, and you can bring out, VCC, ground, XY, RX, TX, and then you just put it into TTL serial to USB port. And so the way I have it wired, there's like in the back of the thing, there's four wires that come out, and you just stick it on your little USB serial port, plug it in, and it works great. So if anybody's interested in that, drop me an email, and because it's sitting in the back of my car, probably on its way over to the makerspace to go on the freebie shelf. So
with all this talk of books around here, it got me to think about one of my favorite books ever.
Okay.
It's entitled Yellow Rain, and the author is P. Off Mountain.
Okay. It's not Yellow Snow, is it, Harold?
Well, no, it's Yellow Rain by P. Off Mountain. You got another one. There's another one there's got another one. It's the Yellow River.
Yeah.
By I.P.
I thought it was the Golden River. No.
You can take me anywhere once, right, Carl? And I'll finish up. I won't make any more promise this time.
No, it's good. Keep it going.
Question of, do you folks know what happens to bad rainbows? Do you know what happens to bad rainbows? Well, they're sentenced to prison. It's a light sentence. Gives them time to reflect.
Oh my God. That's a multi-party issue.
That's what I've been doing the last month and a half. So I'm just saying.
That's a good one, Harold.
Yeah, I think I want to say it's the 500 series. There's a kind of it's not the center button that you use to turn it on with, but kind of off to the left if you're looking at the front of it. There's a little red light that glows through the plastic that indicates something is not working right. But so you can turn it on, it goes through a few moves, a little light comes on and it stops. So I don't, anybody got any ideas as to?
Yeah, there's some of the different models of Roombas have classic failure modes. And if you look up on the web with your particular model, I want to say one of the the one that I had, not the one of the ones I've had sometime in the past, there was that particular model had a MOSFET that had a tendency to blow. And the solution was, you open it up, you unsolder that particular MOSFET and put one in that's got a higher breakdown voltage or something, and the problem goes away and you're okay. But that's the type of problem that some of them had, some classic failure mode that you might take a look at your module. There's so much information on Roombas on the web. It's just incredible.
Yeah. Okay. One website called Robot Reviews has a blog which is just full of information.
Yeah.
Okay. Okay, so no other thoughts besides try to get the Roomba COM app running in Java.
Say that again. Sorry.
Oh, my first question, which was, what's a practical tool for interacting with a Roomba over the serial interface besides something like RealTerm? The Roomba COM app is recommended in the Hacking Robots book and website, and it was supported by somebody from the Dallas Club years ago. Trouble is, it's in Java, it's in a non-compiled form. I haven't done Java programming in 20 years, so I will try to get it compiled and executing inside of a command window. We'll see.
I want to say there was another one, something like making robots with Roomba from Roombas or something, but I don't see it over here. No. It's time to do some pulling.
Be careful, Doug. The minute you throw that book away, you'll be looking for it next month.
No. I've got to start simplifying some stuff. So, anyway.
Okay, well, cool. I think next in queue we had, well, not official, but Mickey, way back around an hour ago, you had asked if you have an IMU in your project box. Are you still online? Should we put that to the crowd and talk about it? Okay, sure. So, Mickey, if you want to unmute your microphone, I'll just read off the question from the chat. So, Mickey asked, if I have an IMU in a project box along with the Raspberry Pi, can I just calibrate that box, even if I have to do it directly above the motor? Well, I have to figure a way to pick up a 75-pound mower and I think rotate it in figure eights to calibrate the IMU.
Yeah, that's what you got to do, Mickey.
And by IMU, you're talking about the magnetometer. Right?
Yeah, I guess, Mickey, is it the BNO 055 you're using or some other? Can you put the model number in chat, or Mike? Okay. I think he does mean by magnetometer.
Aussie Maker Berry.
Aussie Maker Berry GPS IMU. Anybody else know that one?
No, let's go look it up. See if we can find something.
A challenge. This is good. Group accepts the challenge. Let's see. There it is. $74. Perfectly fit with the Raspberry Pi Zero. Here's a link to it. Mickey's chat says it has great Python docs and excellent Python libraries. And I put a link to its ozmaker.com URL in the chat.
So that's everything, including the kitchen sink.
Yep.
Huh. Am I mistaken? Is that the first one, our first instance of this board that our group's encountered?
I think so.
I think so. I want to say I've looked at this, but yeah, there was something I didn't like about it. Let's see. What's the GPS? Oh, no, wait a minute. No, looks good. It gets 3 concurrent systems. That's good. It looks like it gets 4 systems, and it can use 3 of them concurrently.
It uses the LSM6 DSL for gyroscope, accelerometer, and magnetometer. That's interesting.
Yeah. And you say there's excellent libraries with it, Mike?
He said yes in chat. I think his mic isn't working.
Yeah. Okay. Well, that's cool. Look to see it. See your results.
So, but in terms of Mickey's question, calibrating it, it sounds like we don't have experience directly with this one, but here's a link, looks like from its ST Micro data sheet I just put in chat. We do have, I know David and a few others on the line often spend time with the ST Micro parts. We really like those in general.
I've just posted the Adafruit advice on how to calibrate that particular magnetometer that's included in that package. So there's no question you have to calibrate it at some point.
Yeah, no, I'm sure you have to calibrate it.
But to calibrate it, does he have to lift the mower?
Or you have to drive it in a circle.
The old circus
fully
thing where he
calibrated
drives it
though?
in a spear.
Well, I don't think if it's a lawnmower, why do you care very much about the Z-axis unless you have a very hilly lawn? In which case, calibrate it on the hill.
Well, Mickey, what I would try is, I think Tom's got the Adafruit Sensor Lab calibration. There's a couple of utilities in that. That would be, if you go to the link that Tom put in there, you'll see it drawing 3 circles. Do you see that up at the top? If you put it on your mower and let it run this, this program and move your mower around just on the ground and see what you get on it. Okay? And see what type of circles you get, or whether you get anything that looks like that. That would give you, because even though it shows it drawing these circles, they're only using the min and max of these 3 rings. Okay? I should take that back. They use the min and max and the, what do you call it? Minimum and maximum X and minimum and maximum Y of those 3 circles. So if you get something that looks like a circle or a partial circle, you might be able to interpolate what you need. And if you put that in your program, you might get something close. If you think about it, your car just drives around and it calibrates itself. So you probably could just push the mower around and see what sort of output you get when you do that. Am I making sense? Do you follow what I'm saying?
Mickey, I think we're suggesting that certainly it's easy, so you're free to try it outside of the mower, but I think I'm hearing that it's with all of the metal on the mower, part of the issue might be trying to get the calibration to account for all the metal in the mower.
Well, I think you would want it. I think you would want it on a mass. I would suspect that, but you want to do the calibration in the environment that you're going to use it. You follow me? You don't want to do it over here and then put it on your mower. That's not going to do you any good.
Yeah. As far as the 3D orientation goes, you probably want to include all of the attitudes that the lawnmower will go through in its normal traversing of the lawn.
You could probably,
if your lawn is flat, then a flat calibration is fine. If your lawn has a hill, you'll want to include calibration on both level and tipped part of your lawn in order to incorporate the calibration of the Z-axis in the magnetometer.
Isn't that a function also of the algorithm, though? Because like on the B&O 55, for the algorithm to flag itself as in cow, it wants to go through a complete range of each axis.
Or you can do the calibration yourself. Don't use the driver, but decode the driver and write your own, which is what I did with my B&O 55. I wrote my own calibration routines because I wasn't happy with what was in the driver.
Oh.
So I did my own research. That's what I talked about in my presentation a couple of weeks ago.
Right. Okay.
That's all my own code.
Yeah. But I want to say that, if you run your mower, you put it on a mast, run your mower in a couple of circles, tilt it back. Does it have a handle on it still, Mickey? Just tilt it, tilt the deck back and forth like this, and then go around in a circle while you're tilting it up and down, and see what that gets you. And then look at the output from that utility from Adafruit and see what type of circles you get. And like I say, you may not get complete circles. You may only get partial circles. But if you get enough of a circle where you could draw the circle, if you could just say, oh, okay, it looks like it's going to be like this, you could probably take those values and use them.
Is the more electric or gasoline? I'm thinking in terms of, what was the answer? Gas.
Yes.
Okay. I was thinking in terms of the variation in the magnetic fields that may be caused by an electric motor drive. I presume that the gas motor drive would have less variable magnetic fields and more of a fixed hard iron issue.
Oh, sure.
Once you calibrate for the given fixed body of the mower, that's probably good enough and doesn't have to be done too often, as long as there isn't another electrical magnetic influence.
Well, Tom, I think you're right about the body of the mower, but I'm not so sure. On a gas mower, I believe they use a magneto, a big magnet, and then built into the flywheel.
Good point.
I don't know.
That'll be an electric field issue. Maybe, I don't know how much of an.
Well, you're swinging a magnet around.
That's a really good point, Doug.
I don't know. Like I said, I don't know what mowers use now, but I know last time I worked on a mower, that's how they did it.
So get masts of different sizes and calibrate at different heights and see what the difference is.
Yeah. Yeah. And another thing would be, you might take a look at other people. Autonomous mowers are the dream of a lot of people, especially people who cut grass. Anyway, so there's a lot of projects. That would definitely be something you might want to do some research on the internet and see how other people have approached it. Now, I know that some of them use a hidden wire, a wire thing, and I have seen some that use triangulation between, radio antennas and stuff. But I'm sure somebody has tried it with some sort of IMU, and it'd be interesting to see what problems they ran into, and they might have a more educated solution to this.
Vicki, are you planning to attempt any form of odometry with the mower? Wheel sensors.
Ideally.
Yeah. I'm not sure. My gas lawnmower, the wheels tend to slip a lot, so I'm not sure how well that would work.
No, it's not odometry, but he needs speed control, and that's probably where you would use it. Do you see what I'm saying? You're right, Tom. I wouldn't. The odometry probably, at least my wheels were always wore out. So
Yeah. So the other possibility, of course, is differential GPS.
Yes, and to be quite honest, so that's another solution you can look at. It's initially very expensive.
Yeah.
Probably, what is it, Ray? $600?
Probably about 600 to get a good setup, at least.
Yeah, so
active antennas and
but you might look at tractors, people using GPS guided tractors. There's a lot of that. These guys are running these humongous.
You paid $1 million for your tractor. You're not worried about the cost of differential GPS.
Right. Yeah, but I'm just saying that's how they're doing a lot of fields now.
Yep.
Yeah. So.
Yeah, went to the State Fair of Texas last weekend. They always have a John Deere area, and got a quote for a 75 horsepower 5000 series with a air conditioned cab and 3 remotes in the front, or 3 hydraulic connections in the front, 2 in the back, with a 6-foot bush hog. It was only $76,000. I was like, what?
That sounds like my father-in-law, who has my daughter's father-in-law has a big farm in Iowa, and he runs all of his acreage, many acres, 6 times a year. So when he does that, he sends a photo from his office, which basically is him peering over the sports pages as his tractor drives itself around the cornfield.
Yep. Yeah. I was, so I guess I'll keep my little $5,000, probably 50-year-old Massey Ferguson Industrial 40.
Yes.
Cool. Well, Mickey, thanks. That was a great question.
My lawnmower is a $400 Sears special.
Okay, one thing I didn't see. Oh, wait a minute. Oh, there it is. I just want to make sure we captured that Raspberry Zero GPS. Has anybody seen? They're talking about selling Raspberry 5s coming supposedly this week. But I'm just wondering, has anybody seen any Raspberry Zero 2s?
02Ws maybe.
Yeah, I mean you can get zeros pretty easily.
Yeah,
you can go down to Micro Center, but the 2s, the ones that have the essentially the Raspberry 3 chip. Yeah, I haven't seen any of those, and I'm just wondering if anybody had seen any.
There is on Raspberry Pi RPI locator. I think there is some. At least they're showing some in Canada. I ordered some about a month ago from UK actually, and it was delivered. I couldn't believe it was like $3.60 shipping, and the price was approximately the same. I paid approximately $30 Canadian for it. So Raspberry Pi 2W.
Yeah, and that was a month ago. Month ago. About
a month ago, yeah.
Yeah, Micro Center, the Raspberry Pi 02W says sold out. It was $14.99.
Yeah.
But
much good if it's not in stock.
It's a company called Cool Components in the UK that I brought it from.
Mm-hmm.
Well, Mickey, thanks. That's pretty cool. We'll look forward to hearing more about your project, and especially whatever your findings are with that purchase, the ST Micro fancy schmancy part. Osmaker.
Yeah, I would definitely like to see the results of it. Who knows? Maybe that might be the way to go in the future.
Could be. It's got good looking parts on it and a neat form factor, and you can't argue with the name. Osmaker Berry. Okay, well,
Doug, Raspberry RPI locator shows quite a few in the U.S. I don't know if you guys are familiar with that site, rpilocator.com.
Don't know it.
I'll post the link.
Sounds good. Sounds helpful. Okay, I think that brings us to open mic time. All right, so what have we got?
I'll just throw out one question. When I used my 6 Degree of Freedom 6050 IMU, I was very happy with the internal hardware that does the fusion filter, their so-called motion processor. I got it to work quite easily, and I found it gave me very satisfactory results. In our earlier discussion on 9 degree of freedom IMUs, I was just curious if anybody has considered whether to use the internal fusion logic inside of, assuming it's got one, inside of the IMU, because I hear a lot of talk around using external Kalman filters and other kinds of filters. And I just wondered what the thoughts are on the internal hardware filters versus the external software filters. I used the hardware and had good results with it. Also the 6 degree of freedom 6050, its hardware filter is actually a 9 degree of freedom filter and has a secondary I2C interface so that you can connect it up to the 3 degree of freedom magnetometer that I'm planning to use and have the 6050 filter all 9 axes in hardware. And I'm going to try that. I bought some more of those parts, and I'm going to try that out and see how it works. But certainly 6 degrees of freedom, it worked just fine. Nope, no other thoughts? Okay.
Not here. Anyone else? I have some, I think you said 6050s. I have some in a bag on the shelf, but I haven't left the bag since I bought them. So
they're about $1 each, so they're certainly cheap enough to try.
Yeah. If I can only get some time in the bottle from Adafruit, but it doesn't seem to be so readily available.
So many projects, so little time.
Yeah. There's David. Big thumbs up on that last thought too. Yeah. So little. Yeah. All right. Any other topics? Anybody have big plans for the next week? All kinds of project work?
Anybody building a Halloween project?
He's not on tonight, but yeah, there's a guy that does spiders and talking skulls, basically, that track you. And
Yeah, but John isn't here tonight.
right.
I'm hoping to get some work done on my steampunk robot in between all my other projects.
Yeah.
Yeah, I'm battling serious flakiness on my robot platform.
I have to drill some horizontal holes here and avoid the wires that are running through here because I don't want to disassemble that, so that I can run this through the thing and hold that motor up there like I did the other two. I don't have one loose right now that I can show you, but it worked very, very well, much better than my prior version. And then once I get those done, I'll redo my motor controllers, and maybe I'll get this puppy running again. And while I got the motors off, I'm going to rub and buff that PVC and make them look more metallic. I decided it's easier to do it while I'm off instead of while I'm on. I just got to get myself motivated back on that again because I've gotten sidetracked on this astronomy stuff.
Yeah. So many diversions.
I know. Too many hobbies. Good thing I don't work anymore.
You know what? It's sounding more appealing every day.
Yeah, I've got a lot of activities here at the retirement place of beanbag baseball and beach ball volleyball and poker and all that sort of stuff that
My goodness.
takes away from productive work.
Yeah, I know. I'm going to steal the screen for just a minute since Ted talked about the eclipse. Oops, what's all that? I guess that's it. They've changed how you share screens. I'm going to open up. Do you see that?
We see an infinity mirror.
You're not seeing my solar eclipse picture?
No, we see a warning about it avoiding an infinity mirror. So it sounds like we're being drawn in.
Ah, could be. Let me see what else I got here.
You sucked into an alternate dimension, parallel universe.
Oh, entire screen. There we go. That's going to be easier. And then I can show this. Is that visible now?
Oh, yeah.
That's my pictures that I took down at Corpus Christi of the solar eclipse. So I was pretty happy with that.
Yeah,
Showed
that's great.
almost the whole progression.
It's very good. I have a question because I tried to do it and I didn't get that results. I got a nice sort of toward the end, a nice glowing yellowish looking circle. So
Yeah.
what
Yeah.
stops to use and what type of filter and camera?
Well, let me stop sharing and hop back over here again. And I'll be right back from the next room.
Like I know at least one other person that tried it and they didn't get very much better results than I got.
So I had my trusty Nikon D780 with a Nikon 300 prime lens and this trusty little device, which was 2 pieces of PVC, and this, which you may be difficult to see, but it's in there.
I have that filter.
Is that solar film that my astronomy club sold in sheets.
All right.
They were this big a sheet.
Right, right.
2 pieces of paper, and that makes it so the camera can.
So how do you attach that to the camera then? Does it go on top of your lens?
Yeah.
Or
What I did is I just set it on like that.
right.
When the camera was up, wasn't a problem. But when the camera was low, kept falling off, and the darn ranger had to hand it back to me.
But the key is you use that cylinder to sort of keep the rays blocked in. Okay.
Yeah, you can't point the camera to the sun any more than you point your eyes to it.
Well, I had a filter, but the filter I got was the same type of filter that you would use in your glasses, but supposedly it was meant for on top of the your camera, phone camera thing. So
Right.
it's like a piece of paper sleeved like thing.
Right. That's the same idea. I just used PVC because it was
Right.
more solid.
In other words, it wasn't a bigger sheet of paper, so that's why I was wondering about, f-stops and stuff like that, because I don't know.
Yeah.
Yeah, it seemed like it would see it too bright in some
Yeah.
ways for the video, the phone.
My problem I had, you probably didn't notice it on that picture I showed you, but the first couple of pictures were a little bright and fuzzy compared to the others. I had an ISO set at 1600. I thought it had down to 100, and I said, oops, and changed it real quick, and that corrected things. I
Okay,
think
so
I was taking about 1/640th of a second pictures, and I let the f-stops do automatically based on what that would do and everything it was seeing through the camera. So it wasn't really
shutter priority mode.
Yeah, I did speed priority mode, whatever that's called. And I did manual focusing so that it wouldn't try to autofocus through the funny looking filter.
Right. Yeah.
But I was pretty happy with it. It came out mostly good. I'll do better on the next one.
It'll be more black. Yes.
That's right.
Yeah, my wife and I were at Walmart's, and they said, well, you can just go over to aisle 18, and they sell the little, glasses that you can, paper glasses with the film in it. And go over to aisle 18. There's no more of them, so it's like, yeah, okay. So in the delivery area, right, you pull up and, they take your order out to you and load it in your car and all that stuff. Two of the kids had the glasses and they're, looking up at the sun. And I said, can I look at that for a second?
There you go.
Yeah, look at that.
You don't need a lot of it, just a little bit.
Yeah. So, yeah, they work pretty good. I can still see now.
Yep. They're really dark when you're not looking at the sun. You don't see anything.
Yeah.
Right.
Yeah, I kind of wonder if the glass welding helmet would work.
That actually works if you get the right
Shave.
Yeah, they have various different types.
Yeah,
I was standing next to a guy that had a little bitty goggle thing, welding helmet. It was
okay.
all over the head type, and he said, I'm doing just fine. I think he added a secondary filter on his to make super sure that he was good.
Right. I was going to say it needs to be up there. I forget what number exactly offhand, but
There's a number we have for that.
Yeah, what I heard was you had to have a shade 13.
Yeah.
Which is a little darker than normal. Most standard welding helmets that have a single lens are 11s.
Yeah.
Oh, they are.
Now, if you have an auto darkening one, they didn't work because I had one and I tried it. It didn't work because you just can't. You won't trip the sensors even looking at the sign.
Right.
I shouldn't say you wouldn't. Every once in a while, they would trip, and you could see it. You could see that it would work. Okay, but you couldn't keep them tripped. So you really need one that's got like just the old-fashioned filter, welding filter.
Yeah, I want to say his portable ones had 10s. They came with it, and he added an extra 5, is what I think.
Yeah.
Anyway, I just thought I'd throw that out there since
That was excellent.
the conversation started.
That is pretty cool.
Yeah, you're at the right spot.
Okay, now I have a semi-science related thing even further askance. So if you're stuck on airplanes and you need a book to read or something, my wife started me on these. It's the Quantum series. I've read 4 out of the 5.
Mm-hmm.
It starts in it's well-established physics, particle physics, like from the Fermi Labs and the Large Hadron Collector at CERN, or Collider at CERN, but then he goes off into the weeds in a galaxy far, far away, but or a multiverse far, far away. But it's pretty fun how it happens. So if you're looking for a book to read, I've enjoyed it at least. Mm-hmm. And I don't have any.
So you understand what a Higgs boson is now and all that stuff? Or?
Oh yeah.
Yeah. Okay.
Unified field theory. Yeah. The standard model. Oh yeah. Right. Yeah.
Got that down, huh?
Quantum entanglement.
Mm-hmm.
Yeah. String theory.
That's a strange one, boy, I tell you.
There are some funky ones, but it makes for a good read if you're into that kind of thing.
Oh, Carl. Does the type of music therapy your daughter does, is it for stroke victims?
Sorry.
Oh, yeah. So she, she studied the general field of music therapy and became board certified in general. And then she got a certification for neonatal or prenatal, preemies, basically, NICUs. Mm-hmm. So I don't know that she's focused on stroke victims, but the basic concept is that the brain is able. It has different functions might be localized to one part of the brain or another. Right. But the cool thing is that between the two lobes, left and right, there's a few kinds of things that excite both sides of the brain, and music happens to be one of them. So when people suffer, if I understand it, some of the physiology goes that when people have certain kinds of issues, activating that crossover in the brain can help address different kinds of issues. And the one I remember most of all was Gabby. I think that was Congresswoman or Governor Gabby Giffords.
Oh yeah, she got shot in the head.
Someone shot in the head, and they basically destroyed this part of the brain that normally handles speech.
Yeah.
And there's a funny thing where with her condition, the part that handled music and singing was still there fine, but the speech wasn't. So what they wound up doing was to get her they would play songs, pop songs that she knew and liked, and get her to start to sing them. And then that helped her to like retrain other parts of the brain to pick up for the part that was obliterated.
Yeah, a friend of ours had a stroke, and she's having trouble reading and writing.
Yeah.
But she seems to know, she has a pretty eclectic taste in music, everything from, old songs by, Louis Armstrong all the way up to, 70s rock and roll to rap.
Yeah.
And she can like sing along with the song.
Yeah.
Because she knows what the lyrics were. And we were thinking, okay, initially we thought, okay, maybe like a karaoke machine would help. But a lot of karaoke machines, the vocals aren't there. You can, the instrumentals are there, but no vocals. And, we really want something that, basically sings, the lyrics, and also has like a printout of the lyrics, so she can kind of look at the lyrics on the page and also listen to them being sung, and try to associate basically the words on the page with what she's hearing. And so it's kind of sad. She was really pretty sharp, and so I don't know if if that would be beneficial for her. I'm thinking it would probably help some.
Well, there are. I don't know that the insurance is always that favorable. And there are some. Last I heard, my daughter was saying, I think some 33 or so states had a board certification process for music therapists. But you have to be careful because, from what I understand, there are some people will call themselves music therapists, but it's a lot lower. They don't have the training in the physiology and the underlying what's going on. They don't know how to do assessments or monitoring or quantified, or having a treatment plan per se. So some people will call themselves music therapists and just come in and sing with you, and they call that therapy. But the kind of thing that, like I described with Gabby Giffords, where they helped retrain the brain. I mean, that's based on quite a lot of training, actually, and understanding the physiology. So, and there are private practices. So I think if you do your homework, you could probably find them. Or if you want to talk offline, I might be able to help point you where to look.
Oh, that'd be good. Yeah, she lives in Hunt County, and her husband's self-employed, and I think, she tried to get in contact with, the only thing that she could find were speech therapists. And apparently these two women that did it were like so overbooked for the county that, it was impossible to get, an appointment. So,
maybe.
And from what I understood, the sooner you started that, the better. I think if you wait, at least that's what I understood anyway, it wasn't nearly as effective as if you versus starting it right away. So anyway, we should probably talk offline, but I'm kind of hoping that'll help her with that. That's got to be an odd thing, not being able to all of a sudden not read or write, So,
Since we were talking about eclipses, my wife and I tend to travel a lot in the summers, and we were away about 6 years ago when there was a solar eclipse, and wanted to find a way to see it. We hadn't planned for it at all, so I have a little presentation I did here you might find interesting from a scientific point of view. I'll just start that here if I can find it.
Sure.
something other than a pinhole camera.
A little bit different, yeah.
A little bit different.
Well,
This
well,
window.
that works though, because that 1 year, that's why I did.
Yeah, it does work. It's kind of weird, but
I gotta find the
you look a little strange. With
window. Where's the window?
there,
Windows
yeah.
Media Player, right there, I
Other
think.
than that.
Well, you know what's cooler than a pinhole camera is a sieve with all those holes.
So we were on the Salt Spring Island when this took place, off the coast of British Columbia, staying on a small farm, and suddenly we realized there was a solar eclipse happening. So we knew we shouldn't look right at it. So we did some work to build a viewer. Nice pizza box. My camera tripod's in there somewhere. My wife's binoculars. And it worked.
Well, there you go. The white sheet of paper behind
Lots of
it.
duct tape. Lots of duct tape.
Well, you can actually use a pinhole for that too.
Yeah. Well, we had a lot of fun with that one.
Cool.
It's very inventive. You have
It
to be
was a
careful
spur of the
with
moment thing. We were having breakfast up on their balcony where the B&B host likes to serve breakfast, and suddenly realized what was happening.
Yeah, you have to be careful with binoculars, and you can do the same thing with telescopes, that they don't act like a magnifying glass and burn what you're pointing them at. But it sounds like you didn't have that trouble.
Yeah, the intent was to get the projection on the cardboard that we could look at instead of trying to look directly through anything.
Right.
That worked out pretty well.
Yep.
All right. Well, as we go around the table, are there any other comments, Robot, or farther afield things to talk about tonight? If not, I would agree with Pat, who said we had some fun topics, and see you all next week. So have a good evening, guys,
All
Okay.
right, take care.
All right.
and
night.
take it easy.
Yeah. Oh.